In this video, I'm going to show you how to use Firestore and Firebase Authentication together to build a secure, real-time, and offline-enabled app. I'm going to cover data modeling, security rules, and handling offline changes with Firestore SnapshotMetadata. Now, this video is for web developers, but the Firebase principles are the same across all platforms. And it's not a let's build this app style video, and I love those videos. I wanted to just focus on the Firebase parts. So I'm going to build all the Firebase code in one file, and then I'm going to integrate it with some pre-built UI. So if you've been looking for a video that shows you how to do an end-to-end, app with Firebase, then this is the video for you. Let's get started. So what is the app that we're going to build? We are going to be integrating Firebase into a support chat app. And this will handle multiple types of authentication. You can authenticate as a customer or as a support agent. Customers can see their own data and support agents can see all data. And another feature of this chat app is that it's going to handle offline cases. So normally you'll enter in a message online and we can say that it's been delivered because we're syncing that with the server. So now when I magically turn the internet offline, we can see that the message has not been sent to the server. But when I turn it back on, all the messages that were sent while offline are synced back with the server. So starting off with the data model, we are going to have a root collection of support cases. And each support case is going to have a case document that has a case ID. And each case ID will have a path that looks kind of like this, but instead of 1, 2, 3, that will be a generated path from Firestore. Each case document will have a subcollection of messages, and this is where a customer can send in a message to talk to a support agent. Each message will be its own document, and its ID will also be generated by Firestore. Each message is going to have 3 fields: UID, text, and timestamp. This will tell us who sent the message, what the message is, and how to order the message. And every case will also have a type, and it will have a field of UID, and that will tell us who owns the case. So what customer has access to that case. And this takes us to security. We're going to do security through role-based access control with 2 roles, agents and customers. Agents can read all support cases and their messages, and customers can only read their own support cases that they own. And to enforce roles, we're going to have a root collection of users where every single document will be indexed off of the user's UID, which is generated through Firebase Authentication. And then each document of the user will just have a role, so either agent or customer. Okay, so that was the data and security model. We'll get to the security rules in just a bit, but for now, let's dive into the code. Here in my editor, I have my project, which has a bunch of pre-built UI that we are going to hook up to Firebase. Now, this app is built with Vite and Preact. If you're not familiar with either of those, that's okay, because we're going to be writing all of the Firebase code independently. And then at the end, we're just going to hook it up to pre-built components. And we're going to start by opening up the source folder, and we're going to create a file called firebase.js where all of our Firebase code is going to be located. Within this file, I'm going to want to import my config, which I have located right here. And then I'm going to want to initialize 3 packages: Firebase app, Firestore, and Auth. Each one of these has an initialization function or a getter function. You first initialize app, then either Firestore or Auth, and then I'm going to return all 3 from this function. And once those are initialized, I also want to work on connecting them out to the emulators. Within each package, I can import the connect API functions. We call these the connect API because they all start with connect. Now, I only want the emulators to run while I'm on localhost. So I'm going to check the location host name and make sure it's exactly localhost. And if so, then I want to connect. And within each one of these functions, you pass in the service that you want to connect, and then the local host and port. Now, if you're wondering where I got these ports from, if we come over to firebase.json, you'll see that we have all of the emulator ports listed. And that's because I've already set up the emulator. And if you want more information on that, check the link in the descriptions. We got tons of good resources on that. So I have my initialization code, I have my connect code. Let's put them together. I'll create my services and then I will connect them to the emulator just by passing them through. And then now when I return, I will have everything all set up. So what I'm going to do is I'm going to check to see if the Firebase app has already been initialized. And I can do this by calling the getApps method from Firebase app. GetApps is a function that is going to return an array of initialized Firebase apps. And if the array is of length 0, then I know I don't have any apps initialized. Now, you can initialize multiple Firebase apps with different names, but in this case, I'm just going to be relying on one Firebase app. So I know if my array of apps is 0, there hasn't been initialization yet. And if there's no initialization, then I want to connect the emulators. But if there has been initialization already, then I'm going to skip over that part. This right here is a battle-tested app initialization strategy that works across different frameworks and rendering strategies where you can just call the function over and over and over again. Now, ideally, we would do all this app initialization and settings configuration outside of the framework, but that's not always possible or practical. So now we have all of this initialization code done. Let's actually do something with it. Let's read data from Firestore. I'm going to kick off the Firestore emulator with my npm run dev command. You can see that in package.json. It calls Vite as well as the Firestore emulators. Vite is going to run on localhost 3000, and the emulators are going to run on their respective ports we saw in Firebase.json, but the UI is running on 4001. So let's open that up. Here I have authentication and Firestore running. In authentication, we can see I have 2 users, and we can see their UIDs. Inside of the Firestore emulator, I have my support cases data model we saw earlier with the subcollection of messages, and we have 2 messages with 2 user UIDs inside. I'm going to write a function called streamMessages, and this function is going to call the getFirebase method, and remember, we can call that over and over again. And from there, I'm going to import the collection function, pass in Firestore, use the cheating part of the API to pass in the full path, and then I'll need a case ID, which I will expect to come back as a parameter, and then I can finally get to the subcollection of messages. Now I want to write a query, because when you add items to a collection with a generated ID, they are not always going to be in order. So in order to get them back, we're going to write a query in order by timestamp. So I'm going to create a variable called message query and import the query function from Firestore as well as the order by function, and then compose them together to create my query. Okay, so this import statement, it's getting way too big. So I'm going to format this with VS Code. That's so much better. And now I'm going to import the onSnapshot method, which is what I'm going to use to create a real-time listener. I'm going to pass in the message query and then provide a callback, which is going to be called with a new snapshot of data every single time an update occurs. Now, if you are a regular Firestore user, you've used snapshot and called .docs or .changes before, and then mapped off this array of docs to call doc.data to get all of your document data back. But there is so much more that you can do with this document snapshot other than call its data. You can also get its metadata. And this is where you can get all of the useful information about the current network state of the snapshot. You can see if it has any pending writes from the server or if it's from the cache. So what do I mean by a cache? Well, underneath the hood, the Firestore JavaScript SDK is pretty complex. When a lot of developers first start working with Firebase, they can be very mindful about not calling on Snapshot too many times because they don't want to call it to the server unnecessarily. But just because you're using onSnapshot, it doesn't mean that you're always going to be contacting the server. Because underneath the hood, the Firestore JavaScript SDK has a cache. And this cache is really useful because it understands how to sync changes from remote updates, and it even can handle updates for you when you're offline. So using the metadata from the snapshot, I can tell whether the data has been delivered to the server and therefore to other users. And I can do this by taking the inverse of has pending writes. Because if something has pending writes, then it has not been delivered because it still has to go to the server. But if something doesn't have pending writes, then we know that it has been delivered because all of the updates are on the server. All right, now I'm just going to formulate the object that is my message back from this mapping function. So I want to say whether the object has been delivered. I want its ID back from the snapshot. And now I'm just going to spread over all the document data so it becomes just one object. And this will all be in my messages array. But now I have a problem. How do I get this data out of this function? I have these messages and they're stuck inside of onSnapshot. What do? Do I return onSnapshot? No, that just returns the subscription. Do I return these messages? No, they're stuck inside this function. So instead, I'm going to create a function that returns this function, and that function is going to take in a function as a parameter. Now I'm going to take my callback function and call it with the messages that I mapped over from my snapshots documents, and then I can return the outer stream function, and I can use this inside of my components in my Preact app, which, by the way, are functions. Wait, what? That's confusing. David, why do you love functions so much? Well, let me take a second to explain. To use this function that returns a function, I'm going to plug it into my app. So I'm going to go inside of these pages, go into support, and open up the chat box. Like I said before, don't worry too much about this. It's all just pre-built UI. So this chat box, it has a chat list, which renders a list of messages that get passed to it as props. And the chat input, whenever someone hits enter, it will call the onEnter method and call the set messages function, which re-renders the whole app with the new array of messages. And I'm just going to close that for now. I'm going to tap into this component's lifecycle and call the component did mount method. And this method is called when the component starts to exist. And when that happens, it's a great time to do things such as retrieve data, or in our case, set up our stream listener. Inside of component did mount, I'm going to call this stream messages function. Stream messages needs a case ID, which we're going to get in just a second, but it returns out to us our stream function. Now to get the case ID, I can get that by tapping into props that have been passed into the component. This has been set up all with a router that we'll see in a bit, but don't worry too much about this right now, because now it's time to see the magic of the stream function. I'm going to pass in this callback function, and then inside of this stream function, I want to call this same method of props.setMessages, because that's how it tells the application to re-render. And before the browser yells at me, I need to write this .props. And now let's see what's happening. So here, the messages appeared, but obviously one should be from an agent, one should be from yourself, and the only way we can fix that is with authentication. Back in the app, I'm going to go to Firebase.js and import a method called onAuthStateChanged. And this is how we can detect authentication state. The onAuthStateChanged method will tell you if a user is logged in or not. It will fire off null if no user is logged in, or it will fire off with the results of the user if they are. Now, one of the best practices that I have learned from developing JavaScript applications with Firebase is that you want to do your authentication state checks as far up the tree as the UI as you possibly can. Because there are so many spots in your UI that is dependent on that user data. You need to be able to retrieve data based upon their UID. You need to know what route you need to send a user to. So as far up as you can put it is where it should go. So we're not going to put this auth check in chat box, because there are so many other parts of the application that depend on this, including Chatbox itself, because Chatbox wants to know the UID to add a new message. So up here in the very top of our app in main.jsx, we have the app component. This sets our root state, and it even acts as a router, passing down the state of the application throughout the whole tree. But like I said before, this is all pre-built UI, so don't worry too much about it. So let's wire up the auth check. And just like in the Chatbox component, we are going to call component.mount to see when the component exists, and then start our authentication check. So just to make sure it works, I'm going to pass in the callback, and then I'm going to check to see how it looks in the browser. So checking in the dev tools, we can see that it's null, and that's because no user is logged in. But what I can do is I also pre-built a create account and sign in UI. So I'm going to sign in some existing users. Now I'm going to pop open the dev tools, and we have something other than null. It's a real user. And this real user, it has a real UID. And that is what we're going to use when we add new messages. So let's bring that UID down to the chat box. So most routing situations are pretty much going to work the same. If a user exists, great, let's keep going. If a user doesn't exist, let's redirect them to somewhere, maybe where they log in. I'm not going to handle that right now. I'm just going to focus on passing the data down. So now when a user logs in and they exist, that state is going to be passed down into the support component and therefore into the chat box component. And then from here, we can start adding messages with UIDs. And that is what's going to make our app secure. So I'm going to delete this placeholder data and assign the UID from the state.user.uid. So right now, none of this data is being persisted because it's not being saved to Firestore. And if that's the case, then we'll never be able to detect our offline state. So let's go and add that to our Firebase file. With Firestore, you can automatically add documents to a collection and it will automatically generate an ID for you. And this is great when you're dealing with real-time collections because there's less of a chance of a collision because you're not making up or managing any of the names yourself. So for adding a message, we need to create a messages collection, which is similar to what we've done up here. So I'm just going to paste that down into this function, and then we'll also have to pass in a case ID. And now from here, we can call the add doc function, which VS Code automatically imports for me. And then we'll pass in the messages collection and then the data. Now, you might have a keen eye and you might be thinking, why are we copying and pasting this messages collection into a separate function when we already have it in the stream messages function? And you know what? I like your style. Let's combine these two together. I'm going to paste this up here, turn this into an inline function. And then what's so great about this is that I can actually get this all down onto one line and then return from the object. So now we're going to use this add message function within component did mount. So I'm going to pull it out of the stream messages object because it's just a property now. And then I'm going to need to assign this as a method on the class so I can access it inside of chat input. And whenever a user enters a new message, we will have a new message created in Firestore. Back in the browser, I'm going to create a message, hit enter, and just like, I don't see anything. I don't see any errors. What's going on? Let me check the emulator. Wait, there's 3 messages. Oh, there's no timestamp. A quick note about querying an order by. The order by clause will filter out any results that do not contain the ordering property. So when you use order by, make sure that any of the results that you want to retrieve contain that ordering property. Now, whenever a document is going to be added, I want to automatically set up that timestamp. So behind the scenes in add message, I'm going to add a timestamp property. And you might first think, oh, I know what I'm going to do. I'm just going to set a new date, or maybe new date.getTime. But there is a problem with this because you are now relying on the user's time rather than your server's time. And the user, they can lie about their time. So instead of using the user time, let's use the server time on Firebase. And we can get that with the server timestamp function. The server timestamp function will serve as a placeholder until the data gets up to Firebase's server, and then it will be added, and it will be the bona fide time on Firebase's server and not spoofed by the local user. In the emulator, I'm going to delete this document because we don't need it. It doesn't have a timestamp. And then I'm going to go back in and let's create a new message. It's going to be a really good message. Oh, and just like that, it exists. Let's debug it here in the emulator, and there it is. So now our query is working just fine, but let's get the alignment of the messages. So to the right and to the left, depending on who sent it. So to do that, we need to know who sent the message. So inside of the stream callback, I'm going to get the user because it's passed down as a property. And then I'm going to map over the array of messages. And then inside, I'm going to check to see if the person who sent the message is the current user. Then I can set a role as self. So I'll know to align it to the right side. If it's not that UID, then I know it's someone else. So I'll give it to a role of other. And this is all handled in my pre-built UI. Don't worry too much about it. It's just mostly CSS. So it is working. I have my message to the right with a class of message self that's kind of generated because I'm using CSS modules. They're awesome. You should use them. And then also this one has message of other, which means it's the other one. And I'll leave a link in the description to CSS modules for you to check out. The app now works with multiple users. So let's make sure that their data is secure. And we can do that with security rules. Security rules are our language here at Firebase, and they centralize the security to your database and they execute on each and every request. So anytime someone makes a read or a write to your database, it will execute a security rule. Let's take a look. So now I'm gonna go back to my app and open up firestore.rules, which is located here at the root. And let's discuss how security rules work. Think about security rules in the same way that you would think about a router. It's all about matching. We're going to match what service, so Firestore, but then we're going to match this funky little statement, /databases, /curly database, /documents. And this is a statement that says match every single document inside of this database. And then we're going to specify how you can read it with this allow statement. This is where you can specify on what operations will you allow, so read or write, under what expression, whether something is true. And this is at the heart of how we decide what is allowed in the database. We are going to write something simple, but yet at the same time, so complex. We're going to match for the messages that we have within support cases. I'm going to match for the support cases, then the case ID, and then the subcollection of messages. Now this curly brace case ID, this is a wildcard, so it can represent any value. If you've ever worked with a router before and you've seen :ID, this is exactly what that is. So what's important about security rules is that you have to match on a document level, and messages is at the collection level. So what do? Well, match at the document level by providing the wildcard for the message ID. This is effectively the same as saying I want to match all of the documents in the messages collection. Now let's secure it with the allow statement. One thing about allow is that you can specify read and write, but also you can get more granular with that. You can specify create or update or even delete. Also, you can specify list, which is how you specify whether someone can list all of the documents within that collection. Within allow statements, you write expressions, so something that resolves to either true or false. But what do we use to write these expressions? Well, security rules provide you with a whole set of useful variables, such as looking at the request. And then within the request, we can see, is there an authenticated user with that request? And that authenticated user has a UID. And we know all about UIDs. So using that UID, we can say only allow requests to be accessed at this path if the authenticated user's UID from the request matches some UID within this data. And then that way, users who create data can only read, write, list, or whatever you want to specify. They can only list that data that belongs to them. I'm going to use this case ID variable to see who owns the case. And if I take a look in the emulator, we can take a look at each case and we can see our messages, but we also can see this UID. And that UID corresponds with the user in authentication. With security rules, you can actually look up data that exists in the database with the get method. This method right here allows you to get data at a path, inspect its data, and then write a rule for it. So in our case, it would make sense for us to get the case, see who owns it, and check to see if that matches against the request.auth.uid. With the get method, you have to provide the full path of the database, which is just this path up here. And then from there, we can start tapping into the paths we need, which is support cases, and then pass in the parameter for the case ID. And then from here, I can tap into its data property, and this is all of the data that is located at that location. So .data.uid. Now, you might be thinking, whoa, this looks really long in this rule, and I just don't like the way it looks. I wish I could do something cleaner. Well, you're in luck, because with security rules, you can break your code out into smaller functions where you give them their own responsibilities, pass them in parameters, and then they give you your data back. And I find that this makes your rules so much easier to read and use, because now I can call this get case, pass in the case ID, and I know that I'm getting case data back. So I can just tap into .uid and then compare it against request.auth.uid. So one last note, I made a syntax error that I always make. You have to wrap parameters in $signs and parentheses, otherwise it's not gonna work. So in the browser, I can see that my app is running, but how do I know that it's really working? So let me go over to the emulator and click on requests. And this tells me all of the requests that are coming through my database and whether they're succeeding or failing. Clicking into the latest one, we can see exactly where the rule was allowed. And it is what we wrote before. And we can inspect all of the variables like request.auth, the method, the path accessed, even the query. If you scroll through this information, you'll see that the query is being ordered by the timestamp. And this is really helpful for when you're debugging through security rules. So now I have pulled up a new browser and I'm signed in as a guest. So I'm going to log in with a new user who is going to be an agent. And so that way I can flip back and forth and I can see the messages being sent between two users. And opening up the browser, we can see that we can't actually read the data here. So what's going on? Well, if I go to the request monitor, we can see that we are failing on this UID check. And if we look at the UID of the user, we can see that this agent user, who, by the way, I logged into this account behind the scenes, has a different UID. And this UID does not own the case. So how are we going to allow support agents to be able to read cases in addition to users being able to read their own data? Should we assign a support UID field? Well, we could, but there's actually an easier solution, and that's implementing role-based access control. Within the users collection, we can click on our support user and we can see that they have a role of agent. And this role can be used within security rules because we can read data within our security rules. I've done this manually in the database, but usually you would just add this when you create or sign up a user. So what I'd like to do here is say, does the user own the case, or is that current user an agent? And I would like to do this by writing a function and passing in data to check for that user. I'm going to create a function called isAgent, and it's going to check the request object, and then using that UID, it's going to look up the user. And come to think of it, that sounds like a good opportunity for another function. You all know how much I love functions. So calling getUser, I'm going to pass in the user ID, and then just like the getCase function up above, I'm just basically going to copy that and then pass in the user's path. So now with an agent, I will check the role that comes back, and I want to see if they are an agent. But there's actually a more extensible way of doing this. I can use the in operator and then pass in an array. And this is helpful if I add other roles later like admin. But for now, I'm just going to keep it at agent. Oh, and I should remember to return from the function. So now I'm logged in as the agent and I can get the data. But there's something I want to address, and that is handling offline changes. Now, this is the fun part. I'm going to get the app to work offline. Earlier, we discussed Firestore's cache, and one of the benefits of the cache is that if the app loses connection, it can still work offline using the data from the cache. And once the app regains connection, Firestore will sync the changes that happened while offline. And this is where we can see our snapshots metadata in action. Let's do an offline test. So here in the browser, I'm going to open up the DevTools and I'm going to simulate going offline in the network tab. You can throttle your network just for a single tab, and there's even an option to go fully offline. And once you do this, you're going to see all of these errors on the console, and this is normal and expected and the right thing to do. So just ignore those. So now I'm going to enter in a message, and we're going to notice that it's not going to be delivered. And I'm going to inspect this element to see the styling. It has an opacity of 0.75, and that's just the trick that I'm doing to say, hey, this hasn't been delivered visually, but behind the scenes, we're doing this with snapshot metadata. And this is where our snapshot metadata comes into play. If something has pending writes, we will dim the opacity, and if not, then it's just a normal message. So this message hasn't been sent yet, and we can see that in the agents chat. We're still waiting for it to arrive. So if we go back into the network panel and we take this tab back online, we'll see it sent. So Firestore's cache, it knows how to recover from changes when a user loses intermittent connection. So they're in an elevator or the internet drops out real quick. But what happens for a longer term change? Like what happens if the user loses connection, they enter their message, they get all frustrated, and then they refresh the page. And now this user is just completely offline. They can't even access the page. And what happens when you're offline? Well, you get distracted. You might look at your phone, or you might start playing the dino game, and then you realize you're actually really good at the dino game and you just can't lose. You just keep going, and you just play the dino game forever and ever. And then all of a sudden you just get overly confident, and before you know it, oh, it's over. Sorry, what was I doing? That's right. Offline. Okay. All right. So the user, they regain connection. And then when we get back online, the page, our message is gone. So what do? I can't remember my message. I was just playing the dino game for like 15 minutes. What was I writing? Firestore has a cache of data. Why can't that persist even when I'm offline for extended periods of time? And as it turns out, Firestore has such a feature. Back in the editor, I'm going to set up Firestore's long-term offline persistence feature, which is enabled through a function called enable indexed DB persistence. And what this will do is it will allow Firestore to save the cache data into indexed DB. So that way, when the user goes offline for an extended period of time, Firestore can work against that little database and none of the changes will be lost in memory. So let's take the app offline, enter a message, and then refresh. So this time we are not going to get this, maybe just one game. Nope, David, remember, you're making a video. Go back online. Let's see what happens. We've regained connection, and when I scroll down, our message has been synced because there is a connection now. And while this is great, there is still actually one more problem to solve. I'm going to open up this same page in a new tab. And when I pop open the dev tools, we're going to see an error message. Oh no. Error enabling offline persistence, falling back to persistence disabled, failed to obtain exclusive access to the persistence layer. What is going on? This error message is telling us that Firestore can't start offline persistence in this tab because it's already open in another tab. So what do? Can we not just have persistence in multiple tabs? Well, when Firestore first launched, that was the case. But since then, there has been a new feature that solves this problem. So back in our configuration, I'm going to use a new function, and it has a similar name, and it's called enable multi-tab indexed DB persistence. And this right here, as the name would suggest, will allow us to have persistence across multiple tabs. Oh, and one thing I want to mention, because it was a problem for me, sometimes you have to completely shut down your dev server in order for this change to take effect, because you can go back and refresh and then it's not happening. And then you're like, what's going on? I used the new function. It's not working. This is so frustrating. And then you just say, oh, maybe I should just turn it off and turn it back on again. And yeah, that works. So when I go to the browser and I look in the console in both tabs, we don't see any errors, so we know it's working. And you know what? This feature is kind of wild, and I'm going to show you just how. I'm going to go into one tab and I'm going to turn it offline. But then I'm going to go flip into the other tab, which will be online. I'm going to send a message in the online tab, and then I'm going to check the status in the offline tab. And what? I can see the online message in the offline tab, but this one is offline. And I send it, but wait, it's offline, but the message is being sent? Well, that's because here in the online tab, we have a connection and they are being synced across separate tabs. So if one tab has a connection, then it will send the message and we will see that status even in different tabs. Now, it may not be much, but this is an app that can log in multiple users, secure their data, handle different roles across customers and agents, and handle offline changes. So that was a crash course on using Firestore and Firebase Authentication's SDK, as well as security roles. There is still so much more that you can do with Firebase, but right now, do me a favor. Tell me, what kind of style of videos do you prefer? This video was a faster pace crash course that was meant to teach a lot in a little amount of time. But I'm also working on slower paced and longer courses. So leave a comment and let me know what style you prefer and what topics you want to learn. So that's all for today, and I will see you next time.